As a kid growing up in Canada, one of my dreams was always to move to Florida. I thought that would be the coolest thing in the world. So as an adult, I've actually managed to do that. But along the way, I also learned that apparently a lot of other people have that same idea. And apparently about 1,000 people move to Florida every day. We now have almost 22 million residents, and we are the third largest state in the country. That's double the population we had in 1980. As you can see from this, we tend to have a predilection to living in certain parts of the state. Most Floridians would consider themselves to be coastal residents. And in fact, 16 million of us live in coastal counties that are only a few feet above sea level. Now, having said that, given where we are, I would also argue that folks who live in the interior of the state are also coastal citizens. Coastal doesn't just mean the outline of the state. If you think of when a meteorologist is giving the track of an incoming hurricane, that line in no way covers the area of impact of that storm. Coastal includes everything as far inland as the marine environment influences, and offshore as far as the terrestrial environment influences. And this equates to about 100 miles inland, would include Orlando. Think of our afternoon sea breeze collision thunderstorms. That's of marine origin. So if all of Florida is coastal, and all Floridians are coastal citizens, we should all be concerned about coastal issues, because in some way or another we're contributing to those problems. In the summer of 2016, there was a major toxic algal bloom in South Florida. There was a lot of political debate, there was finger pointing, numerous headlines. People were concerned about their health, tourism was decimated, people's lives were turned upside down. People were scared. Now, as a biologist, I might describe this a little differently. So bear with me for a moment while I try and illustrate a point, because a biologist might define this whole scenario somewhat differently than you saw in the media. Now, as a biologist, I would say that South Florida had a massive bloom of microscopic cyanobacteria, also known as blue-green algae, which is actually a member of a phylum of bacteria which has a 3.5 billion-year-old fossil record. These microorganisms are also known to produce a variety of toxins, including neurotoxins and hepatotoxins. The ingestion or inhalation of even small quantities of this can result in asthmatic reactions, allergic reactions, intestinal distress. It can result in larger volumes in neurological problems or complete hepatic failure. If the bloom goes on for very long, it can result in massive fish die-offs, further damaging the ecosystem and exacerbating the social and economic impacts on that community. Okay, enough biology professor speak. We get back to English for a while. The point is that it's very important for us to speak clearly and correctly, but it's also important to be understood. Everything I just told you was biologically correct, but it may not have been understandable or maybe not even relevant. Academics tend to use a lot of jargon. If we're going to deal with coastal issues, we have to speak understandably. So what are the sorts of issues we're dealing with? We hear about new and emerging threats to our environment and our way of life every day. We hear about coastal storm surge, coastal erosion. We hear about toxic algal blooms, which are different from cyanobacteria blooms. We hear about invasive animals. We hear about emerging disease issues like Zika, and on and on and on. South Florida routinely experiences nuisance flooding every afternoon. This disrupts people's lives through road closures, through overwhelmed storm drains, and compromised infrastructure. These floods aren't even related to true storms. These happen on the high tide, simply as a result of land subsidence, sea level rise, and perhaps the removal of natural barriers. Not so long ago, Florida's coastline looked quite different than it does today. And it could look different again in the future. So how are we going to deal with these threats? Some people would suggest that even these complex problems have relatively simple solutions. Unfortunately, I doubt if that's going to be true. Our challenge is going to be able to develop approaches that don't strain our ability to implement them, that engage stakeholders, and ultimately result in safe coastal systems. Some would suggest technology will find the solutions. That may well be true, but it's not going to be the whole solution. This is going to require a team approach. Interdisciplinary teams are pretty common in the business world, but sadly, they're actually quite rare in academia. Universities are a tremendous source of intellectual power. Historically, faculty and students are organized into departments, academic silos. This silo mentality really doesn't encourage cross-discipline interactions. It's not going to be very effective. So we need to tear down the silos and have people of different disciplines working in close proximity to one another. Interdisciplinary also needs to mean more than just STEM. We can't solve these problems with just biologists and chemists and engineers. We need to include the social sciences as well. And that's been lacking in the past. So how do we move forward? First, and this may seem like a pretty simple one, we have to have people working in a common work environment. Bumping into a colleague as you walk across campus is not adequate. Second, we have to share a common language. I said earlier, academics tend to use jargon. The unfortunate thing is, sometimes a word has a different meaning in different disciplines. So here's a little action you can try. Define the term health. Most people here would probably use a definition like the World Health Organization does, where it's a state of complete physical, mental, and social well-being, and not merely a lack of disease or of infirmity. So this means it could be mental health or physical health. It could also be social health. Now, a sociologist may say that social health is the ability to form lasting interpersonal relationships. An economist could walk in the room and say, well, you know, a healthy economy is one with growth, high employment, stable prices. I'm a biologist. I'm going to look at a population and say, basically use these kinds of definitions to apply to individual animals or perhaps a population. Or I might extend it further and look at an ecosystem and see how different species are interacting. So which is it? Ultimately, it's got to be all those things because they all interrelate. Let me share you a little story. I'm going to scale this down from a whole state issue or coastal issue globally down to a smaller scale. Before I came to UCF, I was a professor at Texas A&M University, and I was also the volunteer director of the Marine Mammal Stranding Network. These volunteer networks are found in every coastal state, and their role is to try and assess the cause of death in an animal that comes ashore dead, or to aid in the care of an animal that comes ashore alive. The Texas network is one of the busiest in the country. They can respond to over 300 dolphins a year. Most of them dead, but not all. Some of them are alive. And in the process of doing this, what I suddenly realized, although I didn't think about it at the time as much, is that this is an incredibly interdisciplinary action. You're dealing with lots of people of varying disciplines and backgrounds. From the engaged citizens on the beach who report the stranding and may give initial first aid, may help in transport, through the initial treatment and assessment of the animal, through the long-term rehabilitation process, and hopefully eventually the release of the animal back to the wild. You have people who are lay people who have never even seen a dolphin, to university faculty and students, federal and state agencies, veterinarians, food suppliers, news media, celebrities. You have everybody involved in these things. And the key thing is, all of them have a common goal. It's very clear, it's to rescue the animal. But it's you very quickly realize that they also need a common language, because a misunderstanding can literally be the difference between life or death. Okay, let's scale it back up. Very few of the issues that we face in terms of coastal systems are going to have simple solutions. Sadly, we are more than likely going to see repeats of the devastating events of the summer of 2016, or something similar to it. People are still going to push for the simple fix, but ultimately, if we're going to move forward, we need to fully integrate science and societal needs. We need to break down the silos. We need to have biologists, chemists, and engineers working side by side with anthropologists, sociologists, economists, planners, policy people. We need to fully engage all the users, all the stakeholders, communities, government, and industry. We need to recognize the linkage between the economic security of coastal communities and the ecological security of coastal ecosystems. We have to rethink the whole coastal region and think of it as an integrated social, economic, and ecological system. Only then can we really start to assess policy development and planning and environmental stewardship. I've put together that team. I've got a team at UCF of faculty covering all those disciplines, and more in fact, from 12 different departments in 7 colleges. And we're tackling the issues of coastal sustainability, the health of coastal ecosystems, and ultimately the survival of coastal communities. How we deal with this in 50 years will be radically different than we do today. No question. Technology is going to play a role. But in the end, it's going to boil down to teams of interdisciplinary focused people dealing with issues and speaking a common language. Thank you.